I don't know if your mind works at all like mine. Maybe no one's does. I don't know if that's good or bad, but different anyway. But I was getting ready to do a series of videos on component testers and component kits and so on for the Electronic Workbench series. And it reminded me that something that I haven't talked about is the probes that you use to measure things and the question of calibration and all of that sort of thing. So I'm not going to go into deep metrology, but I think to talk about these probes, which are called Kelvin probes, properly, I would like to at least go back to something that I was taught early in the, back in the 90s. I began attending the NIST metrology, electronic metrology workshops where you got certified in electronic metrology. And I remember right after the coffee on the very first day, the very first thing that the instructor told us, so a group of about, I think it was about 14 or 15 people in that workshop, but he said, I want you, if you don't learn anything else in this course, please learn this one thing. You do not measure resistance. You do not measure impedance. You measure voltage and current, and you compute resistance and impedance. And I'll show you in a minute what he meant. And keeping that in mind, and sometimes I forget it, and I have to come back to it. But the reason that's important is when you really want to measure something like a resistor, what you're really measuring is current through the resistor and voltage across the resistor. And to do that properly, you need 4 wires. So this system is called a 4-wire Kelvin probe. Kelvin because it's named after Lord Kelvin, who was the first to figure out that you had to do it this way. And 4-wire because, we'll come up here to the, you see right in the center, 2 buttons, ohm 2 and ohm 4. What this means is 2-wire measurement of resistance and 2-wire measurement of, or 4-wire measurement of resistance. Now, if you rigidly follow what that NIST instructor, by the way, NIST is National Institute of Standards and Technology, I think. If you follow it, then you don't actually measure resistance, you compute it, but it doesn't matter. The point is that there are 2 ways of doing it. One is a 2-wire, simple, but not very accurate. The other is 4-wire. Not quite so simple, but much more accurate. So let's talk about a little of that, and then we'll talk about Kelvin probes and wrap this all up. Okay, I'm going to try to duplicate the drawing that the NIST instructor put on the board that first day. Suppose that you have something that will measure electrical things. In this case, it's actually going to be an ammeter. In other words, it measures current. Suppose you also have a voltage. Let's in this case say it's a battery. Let's suppose that you connect these to the device under test and measure the amount of current that flows through it. And let's suppose that the device under test is something simple, just a resistor. And you determine that when you put a 10 ohm resistor in the box, you get a certain reading. And when you put a 50 ohm, you get another reading, and so on. And so you calibrate this as an ohm meter. That's the way that the ohm meter function in most multimeters works. But here's the problem. Suppose that you have a fairly low resistance here. If this is 5 meg or so, it doesn't really matter because the length of these leads don't matter. But suppose that you account for the fact that these leads also are little resistors. Now, if you want to determine the actual resistance of this device, you can measure the current through it, because in a series circuit like this, the current is constant. That is, any place you measure it, it's always the same. But if you measure the voltage across here, you're not going to get the right voltage. You have to put the voltage measuring device here, right at the device. Then you can measure the voltage, you measure the current, and then you compute the resistance as voltage over current. Now, the same is true if you're measuring impedance. And if you haven't seen impedance yet, or you're not real clear on it, impedance is just an attempt to take Ohm's law into AC circuits. And the way you do that is you define a term called impedance is the AC voltage divided by the AC current. And in that case, you don't use a DC battery, you use a source of AC. And of course, you have to measure AC current and AC voltage. But once again, if you measure the voltage here, you'll get the wrong answer. If you measure the voltage there, you'll get the right answer. And once again, you compute impedance by knowing the voltage and the current. So, what are Kelvin probes all about? Well, they are an attempt to do exactly what we just talked about. A Kelvin probe has 2 wires on each probe. One of the wires is this wire, and one of the wires is this wire. And the reason that he uses 2 wires is so that the voltmeter can read downstream of the resistance of the test leads. Similarly, the other test lead has 1 wire for this and 1 wire for that. So what happens is the current flows through the whole circuit. The voltmeter only measures the voltage across the device under test, not the voltage coming out of the test equipment. And from that you can compute resistance or impedance, and by using 4 wires, you get an accurate computation of resistance or impedance. Now, this is important when you measure resistors, of course, but it's also important when you measure the impedance of items like inductors and capacitors. Now, this is an LCR meter. It is called the DE5000, and there may be a number of people who are familiar with this. It was originally built by IET Labs, which is the it used to be General Radio and then GenRad, and eventually it became IET Labs. They discontinued this device, I don't know, some years ago, and it's now being built by, I think, maybe a German firm. I'm not sure exactly who builds it, but it's basically a knockoff of the IET device. But it's a very good but fairly low-priced LCR meter. It's not as accurate as some really lab grade, but I will say that it is as accurate as my LC102 over there, and it measures things like the inductance, the capacitance, In the case of inductors, it will measure the Q, which is the quality factor. We're not going to talk about that, but it's something that's important. In a capacitor, it measures dissipation, which is a measure of the quality of a capacitor. But more important than anything else, if you want to get accurate readings with a meter like this, you have to have Kelvin probes. Now, these are Kelvin probes that I added to this meter. It comes with a pair of alligator clips. Now, you may or may not be able to see, but there actually are 3 wires for each clip, or 2 wires per clip plus a ground, or what's in metrology often called the guard. So this is a 4-wire. If you disregard the ground for now, move it out of the way. This is a 4-wire system, but it's a pitiable 4-wire system. It's just almost unusable. So most people, including myself, replace the leads with this set of Kelvin probes. And we do that because we want to get accurate measurements of the voltage and the current from which we can compute, or I should say the meter can compute, because it's the one that's actually doing the work, can compute the resistance in the case of a resistor, or the impedance in the case of any circuit, including a capacitor, an inductor, a resistor, or a combination of those components. But to do that, you need an accurate measure of the current, which is easy because the current is the same throughout the loop. But you also need an accurate measure of the voltage, which is why you need the second pair of wires in a 4-wire system. So I hope this helps explain why that in better quality instruments that measure resistance or impedance, or going back to my old buddy, the NIST instructor, they compute it. But whatever you want to use for your terminology, you need a pair of Kelvin probes, or, to use the generic term, a 4-wire test set. So I hope this has helped clarify in anyone's mind why we use Kelvin probes, and I hope it maybe has encouraged you, if you don't already have a pair of Kelvin probes and you would like to make more accurate measurements, to maybe consider replacing your current probes with, your existing probes, I should say, with a pair of Kelvin probes, and go from a 2-wire system to a 4-wire system. Notice that's what we have over here, is the 4 wires. Okay, enough on metrology, not meteorology. I don't predict the weather. Well, not very well anyway. But I do like to think that I understand a little bit about how you measure things electronic. So, please stay safe. Have a nice day.